Day 143 Notes, Advanced Algebra 2. Today we're looking at a new technique that goes along with our right triangle trigonometry. This technique is called solving right triangles. We're going to use our right triangle trig in order to solve right triangles. Now what that means, if I ask you to solve a right triangle, that means to find all angles and side lengths. Find all angles and side lengths. And since a triangle has 3 sides and 3 angles, that means we're going to find 6 values for each triangle. Now, in order to do this, I find that it's easiest to first label the sides and angles. And we'll talk about how to do that so that we all have a standard understanding for the labeling of our triangles. If I were to give you a triangle, what I would always do is start in the bottom left-hand corner, and I'd call that angle A. Then I'd work in a counterclockwise rotation to call the next angle B, and then finally C. And no matter how the triangle is oriented, I think if we get into that pattern, it would be very easy for us to describe and discuss each of these triangles. So again, I would call this one A, this one B, and then this one C. Now, to go along with that, if we identify each of these angle measures with A, B, and C, we can also indicate the side lengths with A, B, and C as well, only this time we're going to use lowercase letters for each of our side lengths. So capital letters represent angles, lowercase letters represent side lengths. And if you look closely here, you can see the pattern that I use to label each of these sides. Each side length letter matches the angle letter that it's across from. So angle A points across to side length A, angle B points across to side length B, and angle C points across to side length C. Angle A points to side A, angle C points to side C, angle B points to side B. And as I mentioned at the start, if we determine the values of all sides and angles, then our answers could very easily be reported in a small chart like this. And this is what I would like to see for our solutions when I ask you to solve a right triangle. You're going to give me an answer in a chart that looks like this. You have room for side lengths A, B, and C. So side lengths A, B, and C. And you also have room for your angle measures A, B, and C as well. The only thing that you have to be really careful of is that you understand your units of measure for each angle. Some of these problems will be presented to you with angles in degrees. Some of them will be presented to you in radians. So it's very easy to switch between degrees and radians in your calculator. We'll show you how to do that with a couple examples that we see here. So in section 6.2 of the textbook that I'll provide to you, we have this diagram. And the first thing that I would recommend that you do is identify the side lengths and the angle measures by letter. Again, remember what I said. The bottom left-hand corner I would like to call angle A, and then work counterclockwise from there to label the rest of your angles. So A, B, and C would be listed this way. That means we have side length A here, side length B here, and side length C here. Now, based on this given information, we can very easily find what these other values are. But let's first start filling in the values that we know. Angle A, for example, is 45 degrees. Angle B is 90 degrees. Even though it's not written, we have the 90-degree indicator, this square box in the corner. That tells us that angle B is 90 degrees. Side length A is 16 units, and so now all that we need to do is find side length B, C, and angle C. Well, think about it for a moment. What could we do to find angle C, especially if I already have 2 angles known within this triangle? If you started to think that we could subtract these from 180, then you're absolutely right, because 180 degrees is the sum total for all 3 angles. We can subtract 90 and 45 from 180 to find this missing angle. That comes out to be 45 degrees. Now for the missing side lengths, that might not be quite as easy. We'll have to do some trigonometry to find it. If we're going to look for side length B, that's this side over here. That's the hypotenuse of our right triangle. We could set up a right triangle trig problem based on one of the angle measures that was given to us. And I'll start with 45 here. Because directly across from 45 we have a side length, and we can use that to find this missing side length, the hypotenuse. And which rule utilizes the opposite side length and hypotenuse? Well, that would be sine. So if I set up the equation, sine of 45 degrees is equal to 16 divided by b, the side length b that we're looking for, I could set up the proportion and solve for b. b would have to be equal to 16 divided by sine of 45. So 16 divided by sine of 45 degrees. And going to the calculator, we see that 16 divided by sine of 45 degrees is equal to 22.6274. Let's go ahead and round that to just one decimal place. We'll call this 22.6 degrees. 6274. We'll call this 22.6 units. I think I called that degrees just a moment ago. This is not a degree measure because this is a side length. This is 22.6 units, feet, inches, whatever. Now we can also do some calculations in order to find the missing side length for C. This time around I know that angle measure C is 45. I could use that, or I could use the existing angle measure A as 45 degrees. This time if I utilize the opposite side and the adjacent side, that would be a tangent calculation. So tangent of 45 degrees must be equal to the opposite side length, 16, divided by C. When I set up the proportion, then C must be equal to 16 divided by tangent of 45. And we can complete that calculation if you need to with the calculator, or you might recognize that back here we created an isosceles right triangle. If this is an isosceles right triangle, then C must be equal to 16 units, so we can claim that C is 16 there. But for good measure, let's go ahead and check our work with a calculator. 16 divided by tangent of 45 degrees should be equal to 16, and that's exactly what we got here. Side length C is 16 units. We've now solved the right triangle. We have all 6 parts. Let's do the same for number 35. Let's call this one angle A. That's in the left-hand corner. Now, it's not in the bottom, but it is on the leftmost side, so I'll call that A. I'll call this one B and this one C. Therefore, that makes this side length A, this side length B, and this side length C. The values that we know here, angle A is pi divided by 8 units. So that's not a degree measurement, that's a radian measurement. Side length A is unknown, side length B is unknown. No, side length B is known, that one's 33.5 units. It's side length C that we don't know. But we do see that angle B is given to us as well. Now, don't fall into the trap of calling this 90 degrees because that's not correct. We want to call that some sort of value in radians. So 90 degrees when turned into radians would be pi divided by 180. We would multiply these two together, and that result comes out to be pi over 2. So B we'll call pi divided by 2 radians. Now we can calculate C again very quickly, angle C very quickly, because we know that the 3 angle measures have to add up to 180 degrees. But if we're talking about radians, that would be 180 times pi over 180, or in other words, pi radians total. So angle C must be equal to pi radians minus the 2 that were there before. This is just like the last example above when I calculated C. That was 180 degrees minus the 2 known angle measures. This time, since we're dealing with radians, it's pi radians minus pi over 8 minus pi over 2. Again, we can use our calculator to complete this calculation for us. So we'll go with pi minus the fraction pi over 8 minus the fraction pi over 2. And I don't necessarily want the decimal result here, so I'm just going to press enter again and let it calculate it correctly as a fraction. And I'll call that last angle measure 3 pi over 8. 3 pi over 8. Okay, so I've made a little bit of room here. We need to next calculate our missing side length. So we'll calculate side length A first. Now, based on the given information, I have an opposite side length here and a hypotenuse. So the rule that utilizes opposite and hypotenuse is sine. So I'll use sine of pi divided by 8 must be equal to A divided by 33.5. Now again, I can set up a proportion here. If I have these two written as a proportion, let's make it stand out a little bit more obvious here. A divided by 33.5. Then that tells me I should multiply 33.5 times sine of pi over 8 and divide by 1. That'll tell me what A is. Since I know what anything divided by 1 is, I really only have to do this calculation, 33.5 times sine of pi divided by 8. The thing to remember here is that your measurement for your angle was given to you in radians, so your calculator better be set to radians. Let me show you how to do that. We're going to write 33.5 times sine of the fraction pi over 8. Pi over 8. Now before we press equals, we're going to come up to the gear here and we're going to select that and choose the document settings. We're going to change this from degree to radian and press OK. Now when we press enter here, the decimal's okay to get, but when we get our answer here, we know that our degree was calculated based on its radian angle measure. So a value of 12.8 would be correct as a solution, 12.8. So this is 12.8 units long. Side length C is found in a very similar fashion. We have an adjacent side, however, in side length C, and the hypotenuse again. So instead of sine of pi over 8, we have to use cosine of pi over 8, and that must be equal to C divided by 33.5. When I set the proportions equal to one another, I see that I can cross multiply 33.5 times cosine of pi divided by 8, divide that answer by 1, and that tells me what C is. I don't have to divide by 1 since I know that that result will be just the same. So I'll go to the calculator now and identify this result. 33.5 times cosine of pi over 8. So let's create a fraction. We have pi divided by 8. And before I press enter, let me just double check. Yep, I'm still in radians, so I'm in good shape. We'll press enter here and round this result to the nearest tenth, 30.9 units. So C is 30.9 units. And there you have it. We've now solved that triangle, A, B, C for the angle measures and A, B, C for our side lengths. Now for this last example, you'll notice that there are two triangles that we can work with here. And in this problem from the textbook, it's actually asking us to find side length x. What I suggest that you do is consider the two right triangles that are formed. First off, we have a small right triangle that's formed in this corner here. That might be the answers that you produce for this side. And then we have an outer triangle. Let's use a different color, using this side, and now this side. And that makes another triangle that you can identify the values for here. So when it comes to labeling your triangles, if I start with this left-hand triangle first, I would call this angle A, this point is angle B, and this one up here is angle C. So I see that A is 90 degrees. This means that side length A is unknown. Side length B is 85, and side length C is unknown, but I do know that angle B is 60 degrees. For the other triangle, I might call this one A as well. This one becomes B, and this one is C as well. So angle A again is 90 degrees. Angle B this time is 30 degrees. And we have side length A, side length B, and side length C. We know that side length B is also 85 units. If we were solving for letter x, the value of x, the distance from this point to this point along this straight line, that would be equal to the red value C. Let me choose some different colors here. So let's say that x in this problem is equal to the red C minus the blue C. If I had red C, that total length from one side to the other, minus this blue value C, that would give me the total distance for letter X. So I'm going to let you think about this one for a little bit, and I encourage you to try this on your own. Pause the video and work through it, and you can check your solution in just a few moments. Better yet, I'll ask that you solve each triangle and find find X and bring it to class tomorrow. We'll share those on the board. And we'll talk about that solution as well. This is an interesting problem, and it involves the techniques that we've learned today and last week, and it kind of pulls it together into a more advanced problem, which I really like. So again, solve both of these, bring your solution to X, and we'll write them on the board tomorrow, and we'll see who got it correct and how to help those that didn't quite understand the problem.